Our first lesson in our polynomial unit involved expanding and simplifying polynomial expressions, as well as solving some simple linear equations, including some with fractions. Today what we're doing is reviewing some factoring skills, which really is the opposite of expanding and simplifying. So our goal today is to be able to factor a variety of polynomial expressions using a variety of techniques. Factoring is the opposite of expanding, as I said, writing an expression as the product, and when I say product, I'm meaning the multiplication. So product means multiplication, of two or more simpler polynomials. Okay, I'm just adding the word in there of multiplication because some people forget that product is the answer that you get when you multiply two things. So we would have had, or we could have something simple like 3 times 2x plus 7, 2x plus 7. And if we head in this direction, if we actually figure out what that is equal to by multiplying, we're expanding that, we get 6x plus 21. Factoring is starting with something like 6x plus 21 and working it backwards this way to write it as the product of 3x with 2x plus 7. So factoring takes something in what we could call standard form and rewrites it as the product of two or more things. So I'm just going to write the word expanding in here. Expanding or multiplying. All right, so the first type of factoring we should always check for is the common factoring. And the common factoring is when you look at all of your terms and you try to find the biggest number along with the smallest power of the variable that appears in every term. Okay, so the largest number and the smallest power of every variable that appears in every term. Okay, so looking at this first example, if I consider that, I've got the number 16 and 8. Both 8 and 16 can be divided by 8, so the number part of the common factor is 8. Now they both also have an x in them, so x is common, and the smallest power of x is x to the 1. So 8x, or 8x to the 1, is our common factor. That's what goes on the outside of the bracket. And then to get what goes inside, we actually work backwards. Instead of multiplying, we're dividing. So if we take 16x squared and divide it by the 8x, 16 divided by 8 is 2, and x squared divided by x is x. And then we have minus 8x being divided by 8x, and that's minus 1. And I wrote, there we go. Okay, or you can ask yourself, what do we need to multiply 8x by to get back up to the original line? Well, the 8x would have to get multiplied by the 2x to get the 16x squared. It also needs to be multiplied by negative 1 to get the minus 8x. So hopefully that makes sense there. I'm going to just write a little summary beside common factoring as to how it is that we do that. Okay, so hopefully that makes sense. We're writing the expression as the product of the largest number that will divide all terms and the smallest power of the variable that appears in every term with the answer you get when you divide each term by that common factor. There we go. I hope that makes sense to you. So my largest number that would divide the 16 and the 8 was the 8. The smallest power of the x was the x to the 1, and then I take that and write it as the product of the 8x and the answer we get when we divide the original polynomial by that common factor there. All right, looking at the next one, we have a 4, we have an 8, and we have a 10. Out of those numbers, the biggest number that can possibly divide all three of those would be a 2. All terms have an x in it, and the first one has x squared, and second is an x to the 1, and the third is an x cubed. The smallest power of x is just x to the 1, and y appears in every term. We have a y cubed, a y squared, and a y to the 1. Y to the 1 is the smallest power. So that's my common factor, 2xy. Now I'm going to write in the bracket the answer I get when I divide every term by the 2xy. 4 divided by 2 is 2, x squared divided by x is x, and y cubed divided by y is y squared. We're going to need a minus. 4 x divided by x, they cancel each other out, so there's no x's left. We've got a y, because y squared divided by y is just y to the 1, and then plus a 5. X cubed divided by x is x squared, and then y divided by y cancels each other out, so we don't need a y with that one. And that's the factored form of that one. All right, the next one gets into one of the trickier cases. This really is one whole term, and this is a second term, and hopefully you notice that they both have an x minus 5 in common to them. So the common factor for this actually is x take away 5. And if I have this whole term here divided by x take away 5, the x take away 5 kind of cancels out, and it leaves you with a 3x. And in our second term here, the x minus 5 cancels with the x minus 5 that we're dividing by, and we're left with the minus 2. So that's the factored form for that, and that is part of factoring by grouping, which we will be doing later. Now the last, or part D here, is very similar, except you might notice this bracket is x minus y, but this one's y minus x. So they're almost identical. What we're going to do here is common factor. I'm going to leave the first one as it is, the first term as it is. I'm going to common factor -1 out, so it's plus -1 or just subtract 1 of that bracket here. So we've got a negative y now, and then a plus x. So if I take a y, divide by -1, I get negative y, and then a minus x divided by -1, I get a plus x there. Now the reason I'm doing that is so that those brackets are identical now. All right, those brackets will be identical because I can turn these around and put the x first and put the minus y second. And now we have that common x minus y, which can go out front. It's the common factor. It's the thing that both terms can be divided by, and when we divide we get 4x and a take away 1. Okay, so this should be review from years gone by. Now the next page here, let's just resize this. Factoring by grouping. So this gets into more terms. So the last one could have any number of terms, but this one we generally have 4 terms or 6 terms. There's usually an even number of terms here, factoring by grouping. And what we do is we pair, or sometimes we do a 3 and a 1 for a difference of squares, but for our intent and purposes we generally go with just pairs at a time and look for common factors. And then we can do what we did in example C and D from the last group of questions. All right. Okay, so we're pairing terms up and common factoring the pair to lead to a common bracket for factoring. All right, so if I look at the terms in this first example, I have an ax, we have a 3ay, we have bx, and we have a 3by. There's nothing common to all 4 terms. But if I were to pair this first pair up, out of the first one, first 2, a is common to both of them. And when I divide both those terms by a, we get x plus 3y. And then out of the second pair, b is common. And we always need a sign with this. We can't just leave it as a b. You either have to have a plus b or a minus b or whatever it is that's common to both. But you always make sure you have a sign there. If I divide those 2 terms by b, we get x plus 3y. Now that is perfect because we now have these 2 brackets being identical. So now it's like example C up above. And x plus 3y is common to both terms, leaving us with an a and a plus b, which divides out. All right, so you can try the next pair, or the next question, and see if you can pair those up. And I'm going to work through this. All right, I think out of the first 2, I could take 2 and an a common. That would leave me with a 4x and a minus 7. Out of the second pair, the only thing I've got is a 1 that could come out. And that's okay because the 4x minus 7 is what I want to have in the bracket. So the 4x minus 7 is the common piece. You could have paired these up differently. You might want to choose to put the 8 and the 4x together, and then put these two together, and that's okay too. Whatever works. In the end, your two brackets should be identical to these ones. All right, let's see if we can pair these up here. I'm going to go with the first two and the last two. Again, you could pair these differently if you wish, but this should work. I'm going to take an x squared out of the first pair. The second pair, I'm just taking a +1. It doesn't change it, but that's okay because I do want my second bracket anyway to be an x minus 2 to match the first bracket. Now that's going to leave me with an x minus 2 times an x squared plus 1. Okay, and the last example. Now there's 6 terms this time, but you might see a pattern here. There's an A and an A, and a B and a B, and a 2 and a 2. So I'm actually going to just pair these up, but it's going to be 3 pairs this time. First pair has A in common, and we get an x plus 1. The second pair has B in common, so plus B, x plus 1. And the third pair has a 2 in common with an x plus 1. So the x plus 1 is common to all 3, so it leaves us with x plus 1 as our common factor. And when I divide each of the 3 terms, the first term divides by x plus 1, we're left with an A. The second term divides by x plus 1, we're left with a B. The third term divides by x plus 1, and it leaves us with a plus 2.